I'm going to start with something maybe a little bit more simple, and then we can look at ones that are a little bit different. So let's start with problem number one. So draw an angle with the given measure and standard position. So remember, standard position of an angle is just when it's on an XY coordinate grid where the initial side is on the positive x-axis. And then the terminal side is where the angle ends. So that's standard form. So I just want you to sketch that angle with degrees and radians. So 1 through 3 is degrees here, and 4 through 6 are radians. So 1 is simple. It's the simplest one there is. Just in standard position, find 170 degrees. You don't need to be absolutely exact on this. So if I just want to write it in standard position, I'm going to graph my initial side. I know that 170 degrees is really close to 180. So it might help to label the quadrantal angles where that's 0 degrees or 360 degrees. That's 90. That's 180. That's 270, which is 180 plus 90. And then 360. So 170 is really close to 180. So you can just draw the terminal side here and say that's 170. And you're done. All right, so problem 2 is a little bit more complex because 540 degrees is greater than 360. So what you need to do is figure out what angle is 540 degrees coterminal to. All right, so remember a coterminal angle if you have like 10 degrees. Well, that's 10 degrees, but it's going to look exactly the same, the angle, if you add 360 to that and have 370 degrees. So 10 degrees and 370 degrees are coterminal. So one way you can find a coterminal angle, especially if it's positive, is just to take the angle like 370 and subtract 360. So we can do the same thing here. I've got 540 minus 360. I'm doing this by hand. All right. I do that right? Just checking. Yep. In other words, when it's saying to graph or sketch 540 in standard form, I'm going to draw the axes. I'm going to draw the initial side. I'm going to go full revolution of 360 degrees. But 540 is just 360 plus another 180. And if you recall back in the previous example, 180 was just the straight line. It's over here. I can draw the terminal side and say that that is 540 degrees. And so that would be your response. Okay. So let's take a look at problem number 6. And so problem 6, the same thing, draw an angle with a given measure and standard position. And it's negative 3 pi over 4. Now, here, what you kind of need to remember is that when you've got standard position, normally a positive angle is counterclockwise. So it's opposite to a clock. I know it's hard to see the movement on here. It's not translating well, but like a regular positive angle, say like 100 degrees, goes this way. But a negative angle goes the other way. So if I had negative 100 degrees, I'd go negative 90. See if I can show this better. Negative 90 and then another negative 10. And so if I went this way, that would be negative 100 degrees. I've got my initial side and my terminal side. So for this problem in radians, I need to, instead of moving positively, I need to move negatively. This is where it helps to really kind of understand radians a little bit better, particularly the fractions of radians. So negative 3 pi over 4 is equivalent to 3 negative pi over 4s. Adjust the focus here. But pi over 4 is the same as 45 degrees. And 45 degrees is half of 90. I think we all know that, like, if you've got a 45-degree angle over here, it looks like that. In other words, I've got negative 3 45-degree angles. So if I wanted to graph that in standard position, I would find one 45-degree angle, a second, and then a third. But I'm not writing that in degrees, I'm writing that in radians, so I'm going to write that as negative 3 pi over 4.